Okay, so with complex numbers, what we have to worry about with complex numbers is that we have imaginary numbers. And imaginary numbers sounds like what it is. It's numbers that they're made up. You cannot find, when we talk about imaginary numbers, you're not able to really find them on the number line. We have to kind of manipulate it a little bit to show you, to get some representation of it. But basically, imaginary numbers, they're always going to use the I variable. And whenever you see the I variable, it will always be, now it won't have the asterisks around it like this that we're talking about, but it always will be italicized. When they talk about the I variable, it won't be just like this. They won't show it like that. It'll always be the italics where it's always kind of, got the curviness to it. And the big thing of that you've got to catch on this one, and it's not even really I, it's more of I squared, is that I squared is going to equal -1 because I is just the variable itself. And here's the catch on this one. Here's where we're going to use this. Up until now, if we were doing square root of -25, because we've done this a time or two with some different things along the way, what was the answer if we did the square root of -25? All right, if it was square root of 25, it'd be 5. If we put a negative in there, you get an error message, right? Because we said you cannot square root a negative number, because when you're square rooting something, it's got to be the same number times itself. Well, if you do a positive times a positive, it gives you a positive. If you do a negative times a negative, it gives you a positive. So square root of 25 would be 5. We get that. Right now, if we did this one, this would basically be no solution or undefined, or one of those type things. So here's where we're going to use this one. So now what we're going to do for all these problems is we're going to replace the negative with I squared. Okay, and it's actually like a two-step process to get us there, because, we'll do the first one this way. After this, we won't do it like this. But technically, if we took square root of -25, you could rewrite that as -1 times 25. Okay, and then once we've got the -1 here, we can take this -1 and replace it with I squared. But whenever we write numbers, we always put the variable at the end of it. So then once we've got it here, we'll kind of go back and rearrange it. So make it 25 times I squared. And then you can break it down to two parts. If you square root 25, that would be 5. If you square rooted I squared, that would just be I. Okay. And I know in the past we did some stuff with these, and we put pluses and minuses because, kind of like we're saying, that if you did the square root of 25, it could be that you could do 5 times 5, or if you did the square root of 25, it could be -5 times -5. So sometimes we put the plus or minus in there. For this part of it with imaginary numbers, you don't have to worry about doing that one. You can just leave the answer as just a plain old 5i. Okay, so we'll just put some bullets over here so you can see the different examples. So if we did another one, let's say it was square root of -49. All right, if it was the square root of 49, we know it would be 7. But with this one, we're going to take out the negative and basically put an I squared in that negative place. So if we square root 49 at 7, if you square root I squared, that's going to be 7i. And some people just start going, well, so the only difference between a positive square root and a negative square root is that if we did a positive square root, the answer would just be 5. If we do a negative square root, we're going to put an I in there. And I'm like, yeah, that's the whole connection. That's what they want you to see. This I, if you do this, lets you know you started off with a negative square root that normally you don't get a real answer. So now we're giving it an imaginary answer. And it took me a few years. This actually was like 3 or 4 years ago. I was talking to a teacher that used to be next door over here where Coach Brewer is. And I said, hey, we're doing imaginary numbers right now because we were both teaching algebra 2. We got to this point. I said, have you ever used imaginary numbers in your life or know where it's used? I said, because I don't. I said, I've never used it. And he said, yes. He said he was talking to a kid in class one day, and they were talking about this, how would they use it. And he said, my dad's an electrician, he's an electrical engineer. And he said, with electricity, a lot of times they use I and J variables with vectors and different things. And he said, so electricians actually use the I variable because you can actually get a negative flow in electricity where it goes the wrong way. He said, so this is where they kind of come back in and use this. You talk about the I variable a little bit in pre-cal, and then you don't talk about it again until you get to calculus 3. Like cal 1 and cal 2, you don't do it. So it's not something you use a lot, but there's a few little minute applications where you actually would use some of this stuff. So anyway, so that's what we're looking at. Probably the biggest thing y'all are going to have to worry about when we do one of these is if you have to do the square root of negative 12. Okay, because it's not a perfect square root. So if we did take this thing and rearrange it, it would be 12I squared. And once you get it to here, this is where you've got to go back to this is where we go back to middle school. You've got to take the 12 and you got to start breaking it down using the old factor trees. You're going to do 2 times 6 to get that. And if you remember, 2 is a prime number, so you'd circle that one. 6 would be 2 times 3. Both of those are prime numbers. Okay, so if we rewrote it, it would look something like this. Okay, and actually, hang on a second. Let me scratch it out for a minute. Let's just do the square root of 12 if we're going to do this one, just so we can kind of see it, because it's easier if we just do that part. If we did square root of 12, that'd be 2 times 2 times 3. Okay, and everybody's got their different ways of thinking about these and going through stuff. I kind of like using like the exit buddy method. Okay, so when we're doing our exit buddies, got to have a buddy that looks just like himself. Now, a little bit different from what we had before. But if you've got 2 times, because here's what it is basically. If you have 2 of the same things, if you had 2 times 2, that would be 4. If you took the square root of 4, that's going to make that 2. The 3 doesn't have a buddy, so it stays on the inside. So if you had to take 12 and break it down, it would be 2 square root of 3. The only difference between 12 and negative 12 is that when we do the negative 12 and we put the I squared in there, this answer is going to be 2 square root of 3, and just put an I on the end of it. Okay, and that's probably going to be the hardest part is when you have a number that's not a perfect square root of going back and breaking it down. And we'll just keep working on that a little bit today. We'll come back to some in the next couple of days and kind of look at it too. But that's the biggest thing that you have to kind of worry about is just taking different numbers that aren't perfect square roots and going back and breaking them down to get those. So I kind of like doing the exit buddy method because it just seems like it sticks a little better that you got to have 2 of the same thing to get this thing out of the square root. So, if you got a pair of 2s, well, then that 2 gets out. 3 doesn't have a buddy, so 3 stays on the inside. Okay, so that's kind of one way of thinking about it here. The other little thing that they talk about with complex numbers is complex number form. And that is A plus BI form. That when they talk about putting something in complex form, basically is this part. Anything that's got a real number, that part would go first. If it's got the I part of it, which is the imaginary part of it, that number is going to go second. Now, and one thing back up here with this last question, I almost forgot about this one. Sometimes with the problem, I kind of like having this problem this way. Occasionally when we'll go through some of the problems here in Math Excel, they'll put this I in front of the square root. I don't like it that way, but occasionally they will give you an answer that looks like that. I like it much better when it's at the end, but with Math Excel, that's something I found that they do that I don't really like, but occasionally they'll sneak that I and put it in here. To me, this is the better answer, but just realize that sometimes they may do something like this. So if you get a question and you miss it, hopefully they'll tell you, hey, you've got this in the correct form. You just have to move the I variable so that you know that you can kind of get it there. But this is the way it should be, but occasionally they'll sneak it in and make it look something like that. All right, so with complex form, sometimes they're going to make you kind of rewrite this one so that you have a number that maybe is not in complex form and you've got to rewrite it. So what we'll do is this. Let's say you're doing a problem and you've got an answer that's here. And we'll do like 2 or 3 of these. And you've got to turn around then and rewrite it in complex form. So if you have negative 6I plus 3 is your answer, And if they tell you to turn around and rewrite it in complex form or a plus bi form, you just got to take this 3 that's your real number and put it first. The negative 6i that's the imaginary number, that would have to go second. So it'd be something like that. All right. The other two that we'll do are kind of, I guess, a little bit weird, a little different. And we'll show you this one. Really, it's more for one thing that you have to do when we're doing some of these problems. If your answer is 2, if it just tells you to simplify it, that's perfect. That would be fine. But sometimes if you have an answer, they may ask you to graph some of these or do some things with it. So if you have to write it in like a true complex form, you'd have to rewrite this as 2 plus 0i. Okay, and there's really only one time that you have to do that, and we'll show you when you would need this. The other times, if it just tells you to simplify, 2 is just fine. All right, and then the last case is if you have something like 7i. Well, same thing. The I would go at the end. You basically put a 0 in front for a placeholder. So it'd be like 0 plus 7i. Okay, now the only time you really need to do this, where you've got an answer that's this clean to make it look like this, there's only really one time that you have to worry about doing this. And this is when you're doing graphing complex numbers. And once you see the graphs on these, you go, well, that's not really bad at all. It's really straightforward when it comes off of it. So if you have something that's in the a plus bi form, when you're graphing these complex numbers, basically the a value becomes the x and the b value becomes the y to get an ordered pair. Okay, and that's the only reason why you really would have to take an answer that's like this to write it in complex form, so that if you had to write it in ordered pair form, you would know that this answer would be at 2, 0, and this answer would be at 0, 7. This one's okay because it'd be 3, negative 6. That one's not a big deal. But these two, if you don't put the zeros in place, sometimes people miss those because they're like, well, how am I going to graph just a 2? Okay, so you've got to rewrite this as an ordered pair when it comes off of it. So that's the only time you really have to worry about writing it in like a true complex form if this was your answer. That if you've got to graph it, then yeah, you need to go back and rewrite it like this, so then you come back and graph those numbers. Okay, so let's do this. Let's make just a quick little XY axis, and then we'll graph like 3 points, which won't take long, just so then we make sure we got it. And then we've got one more thing we have to do with the a plus bi form to show you what that part would be. All right, so for a, let's say it's going to be 5 minus 2i. Okay, so first thing is, again, you need it as an ordered pair, so basically just pull out these two numbers and make it 5, negative 2. Okay, so go to 5, negative 2, put a dot right there, and that would be a. If they ask you to graph b, so it's negative 3 plus I. For that one, first number is negative 3, so we're good there. And remember, because you have an I that's there, technically that would be 1I, so that would be negative 3, 1 for your ordered pair. So B would be about there. Okay, and then the last one that we'll do will be if we just had 5I. Okay, now in that case, there's nothing in front of you've got the 5 that's here, so that's the second part of it. If there's nothing there, that's when you'd put in the 0. Okay, so 0, 5 would put you up right here, and that would be point C. Okay, so graphing complex numbers, really not bad at all. And again, that's just kind of going through some different things. That's the only way you can really graph those. That's one that, you know, they have to specify that it was a complex number, because if they just gave you a graph like this and said, what are these ordered pairs? You know, there's no way of knowing that those are complex numbers. So they'll have to give you the numbers first, and that's how you would graph a complex number when it comes off of that. Question.
Graph like -12 or anything like that?
If they had you graph a number that was bigger than those, they probably would do something like this where the numbers. Mm-hmm. Oh, no, it won't be a square root like that. No, it'll be whole numbers when you graph these. Yeah, there shouldn't be any decimals or square roots or anything like that on this part. Okay, and then the last thing that we're going to do with this absolute value with the complex numbers like this one is we're going to find the absolute value of complex numbers. Okay, and even this one's not too bad once you kind of see the setup on this. Okay, so whatever complex number they give to you, they're going to tell you to find the absolute value of whatever this complex number is. So to find the absolute value of it, then all you have to do is you're going to take the square root, kind of like we did the order pairs here. Basically, you pull out the order pair numbers that you would have, which would be the A and the B values, and you square both of those numbers, and then you take the square root of that answer. Okay, so if they tell you to find the absolute value of 5 minus 2i, again, all you do is you take the first number, square it, you take the second number, and you square that. Okay, and from here, it's just pretty much order of operations. And if you have something like this, you go ahead and do the first number squared. So 5 times 5 is 25. If you do -2 times -2, that's still going to be a +4. And 25 plus, then you can go ahead and add the numbers, 25 plus 4 to make it 29. Okay, if you can break this number down, you go ahead and do this. Now, if you're like, how do I know if I break numbers down? If it's even, of course, you can divide it by 2. If it's odd, you go back and start checking it by all the odd numbers. You know, if you divide it by 3, well, that won't work because 30's, you know, you have to get 3 times 10 to get 30, or 3 times 9 is 27. So if you get something and you're not really sure about if it's divisible by something, just start taking it and checking it. If it comes out to be a whole number, then you can divide it. You can't divide it by 3. You know, it's not going to divide by 5 because that would get you at 30. It won't work with 7 because 7 times 4 is 28. So 29 is a little bit bigger than 4. And if you checked it with 9, it's not going to work. And if you checked it with 11. So if you go through and start checking all the odd numbers, oh, sorry, so 11. None of the odd numbers work. So in that case, 29, you can't break it down any farther. So that would just be your final answer. All right, so let me give you one that you can break down to get an answer that you could break it down just a little bit. Let's do the absolute value of -4 plus 2i. Okay, so all we're going to do is we're going to do the square root of the first number squared and the second number squared. Okay, -4 times -4 is 16. 2 times 2 is 4. So it's square root of 20. Now, again, 20 is even, so you know you can divide it by 2. Now, there'll be some odd numbers that even though you can divide them by 2, you won't get any buddies. But if we take 20 and break it down, I'll do it over here on the side. You could do 2 times 10. You could do 2 times 5, and 5 is a prime number. And if you remember, most of your prime numbers are 2s, 3s, and 5s. That's your big 3. 7 sneaks in there sometimes. You get an 11 occasionally. Sometimes you get a 13. But really, your big 3 numbers that you get are 2, 3s, and 5s. if you want to put a big 4, number 7 would be the next on the list. So if we took 20 to break it down, it's 2 times 2 times 5. Well, there's your exit buddies. So the 2's get out, and the 5 doesn't. So that final answer would be 2 square root of 5. Okay, so absolute value, it's about a 50-50 shot. Some of them break down, some of them don't. It just really just depends on the numbers when you're going through those. All right, and then the last couple of things. That's about as far as we'll get. We didn't quite get everything, but we'll get the rest of it tomorrow when we come through. The last couple of things with complex numbers. Is first thing they're going to ask you to either add or subtract complex numbers. Okay. And the big thing with this one is that you're going to treat I just like any other variable. It'd be no different if we were doing, 2x plus 3 plus 6x minus 12 or something like that. The I is just anything else. That really, when you're doing this one, you're going to combine like terms. In this part, I know y'all been doing this since like 6th grade. I know you did in Algebra 1. I know you did it in 8th grade. I know you did it in 7th grade. Probably back in 6th grade you did some of this. The difference is now instead of using 2x plus 3, we're going to use 2I plus 3, something like that. So let's give you a couple. We'll do like 3 examples in this one. So let's do 3 plus 2I plus negative 6 plus 5I. Okay, and you may say, well, why they've got these in parentheses? Basically, they're saying this is one complex number, and this is another complex number, and they're either going to give you a plus sign where you add them, or they give you a minus sign if you subtract them. If it's an addition sign in the middle, it's really about the easiest thing that you can get, because all you're going to do is that there's nothing to do with this parentheses, there's nothing to do with this parentheses. So basically, you just find the like terms. Well, that's the 3 and the negative 6. So that becomes 3 plus negative 6. Well, then you've got a 2I and a 5I, so that becomes plus 2I plus 5I. Okay. And then just do the math. 3 plus negative 6, 3 minus 6, that's negative 3. 2I plus 5I is 7I. There you go. And that's your final answer. If that seems like that's pretty easy, it is. There's not. Here's the only trick to combining like 10. It's not really a trick. It's just you have to be careful with it. Because there's not really, this is the closest thing to a curveball that, if you had a problem like this one, this would be the only thing that might throw people for a loop sometimes. So if it's a subtraction problem, we've got 4I or 4 minus 5I minus 6 minus 9I. Okay. The good thing about addition sign, when we have this one, you don't change any signs at all. Everything is the same. If you have a subtraction problem like this, remember that basically if we did like distributed property, like way back when we were doing some distributed property, that this is basically like negative 1 times 6 minus 9I. So if you do that, it's negative 1 times 6 to make that negative 6. And everybody gets that part of it. It's always the second problem that if you haven't done these in a while, will get you. Because if it's negative 1 times negative 9, that's going to be a positive 9I. And that's the one that usually gets people, because they'll get to that one and they're like, oh, I forgot to change that sign. So you got to change this sign and you've got to change that sign if there's a minus that's in front. Okay. And again, you really don't need the parentheses on the first one. It's just there for a marker just to let you know. And once you've changed these signs back here, now you can go back in and rearrange everything. Now it's 4 minus 6 for the numbers. And then it's -5 plus 9 for the I variables. So it's -2 plus 4I. And here's really the one thing, this is the only trick you have to watch out for that you have to be careful of, is make sure to change both numbers signs. Seems funny to say that. I guess I should have said the sign of both numbers in the parentheses to the right of a subtraction sign. Because again, technically it's like having a -1 there, that you're doing distributive property with a -1 and then you're making it that way. Okay, and that's the closest thing to a trick question they'll give you with adding and subtracting. Everything else is straightforward. Just add the numbers together or subtract the numbers depending on the sign they give to you. Whatever you have with the variables, it's got the I on it. Same thing. You either add or subtract those based on what the signs are. All right, let me give you one more of those. And show you one last thing real quick, and then we'll wrap it up for today. Okay, so let's go with -7 plus 3I minus -5 plus 4I. Okay, again, you never really do anything with the first parentheses because there's nothing in front of it. If there was a minus sign here, you'd change it, but there's not anything here. And again, because of the minus sign that's here, you're going to do minus the -5, so that would be a +5. And if you do minus the -4, it's going to make it a minus 4I. Again, you got to think about this -1 times this one, and it's -1 times that one. You know, if you're one of those people that you're visual, you need to see that step, you can write it out. But you know, if you kind of get thinking about it after you do enough of them, you can hopefully kind of skip that and just realize, okay, I got to change this sign, and I got to change that sign. Once you've done that, now we can rearrange it. It's -7 plus 5, and then plus 3I minus 4I. Okay, so that's -2. 3 minus 4 is -1. That answer would be okay. Probably the better answer would be just to leave it like that without the 1I. Okay, and we've got about 2 minutes before the bell. So there's one. I was going to show you some multiplication. Not a big deal because we can show you that one tomorrow because it's pretty straightforward too. So we'll pick up there tomorrow with this part of it.